Mrs.Mini, Assistant Professor from Emmanuel Arasa JJ College of Engineering. I am going to present the topic about PN junction diode. In this lecture, I am going to explain about the definition of PN junction diode, its construction, working principle, applications, and finally conclusion. What is PN junction diode? It's a semiconductor device, which means it's a material whose electrical conductivity lies between a conductor and an insulator. Example, we will say that silicon and germanium. At low temperature, the semiconductor act like insulators, and at high temperature, it acts as a conductor. While joining a p-type semiconductor, this is the symbolic representation of PN junction diode. A represents positive and C represents cathode, that means negative. The current flows from anode to cathode. That's why we will say that this is a unidirectional bipolar device. This is the construction of PN junction diode. In this p-type material, majority carriers as holes which have positive charge and minority carriers as electrons which have negative charge. Similarly, in n-type region, the majority carriers as electrons and the minority carriers as holes. The junction between them is called PN junction diode. When no external source is connected to the PN junction, diffusion takes place. Diffusion means the process by which particles such as atoms, ions or molecules move from an area of high concentration to low concentration until they are evenly spread out. That is, these electrons are attracted by holes and the holes are attracted by electrons. At the junction, these electrons and holes combine to form the region called depletion region. In this depletion region, there is no free charge carriers. Actually, this depletion layer acts as a barrier to current flow. In order to move the electrons and holes, we need the external supply. That is called biasing. There are two types of biasing. The first type of biasing is forward bias. In this forward bias, p-type region is connected to the positive terminal of the battery and the n-type region is connected to negative terminal. Now, the electrons are attracted by holes and the holes are attracted by electrons. The depletion layer becomes very thin and the current flows easily through the diode. This is the graphical representation of PN junction diode at forward bias. This x-axis denoted by forward voltage and the y-axis is forward current. This forward voltage increases or when the voltage increases up to less than barrier voltage, there is no current flow. The barrier voltage of silicon is 0.7 and the germanium is 0.3. When it crosses this barrier voltage, the diode starts to conduct and the current flows. This knee voltage is also called the cut-in voltage or threshold voltage of PN junction diode, which is the minimum forward voltage at which the diode starts to conduct. Once this applied voltage reaches this knee value, the barrier potential is overcome and the conduction begins. Another type of biasing is reverse bias. Here the positive region is connected to negative terminal of the battery and negative region is connected to positive terminal of the battery. Now, holes are attracted by negative terminals of the battery and electrons are flow towards the positive terminal of the battery. Only minority carriers are present inside the P region and N region. Due to this, the depletion region width increases, the diode does not conduct. This is the voltage current characteristics of PN junction diode in reverse bias. As we increase the reverse bias, breakdown occurs when the reverse voltage increases. The minority carriers get energy from this and move quickly to each other. The collision occurs. For each collision, it releases the additional electron-hole pair. This process multiplies, which leads to avalanche effect or avalanche multiplication, which is called as avalanche breakdown. During this avalanche breakdown, a large current suddenly flows through the diode. It will generate the heat. When we touch the diode, we may feel the heat. Therefore, this PN junction diode is not suitable in reverse bias because it gets damaged in this reverse bias condition. Some of the applications of PN junction diode is rectifiers, clippers and clampers, switching circuits, and reduction and demodulation. As we conclude that the PN junction diode demonstrates how semiconductor technology can control the current flow through its forward and reverse bias properties. It enables many applications from power supplies to communication systems. Hence, it is considered the foundation of all semiconductor devices. Thank you.